Good day, math learners! Welcome to session 12, writing the standard form of the equation of an ellipse and describing the ellipse in its two orientations, the vertical and horizontal orientations. Before we begin, do not forget to subscribe and click the notification bell so that you will be notified whenever I post new video lessons online. Let's begin! The ellipses we have considered so far, the center of those ellipses that we have talked so far, have their centers at the origin. But you know, there are some ellipses which have their center not at the origin, but rather on other parts of the Cartesian coordinate system, maybe at the first, second, or third, or fourth quadrant. And in these ellipses, their foci are aligned vertically, though some are aligned horizontally, but the center is not anymore at the origin. And for some, the foci is aligned vertically, meaning the ellipse is vertical in form. The major axis would be standing, unlike the ones that we have discussed, wherein the major axis were horizontal. Okay, so in this table, I'm going to present to you the summarized form of the equations of an ellipse and their corresponding graphs, and their corresponding equations in standard form. But in all of these four cases, A is always greater than B, and C is equal to the square root of A squared minus B squared. And as what we have discussed before, the foci f sub 1 and f sub 2 are C units away from the center, and the vertices v sub 1 and v sub 2 are A units away from the center. The major axis has length 2A, and the co-vertices, which we denote as W sub 1 and W sub 2, are B units away from the center. And lastly, the minor axis has length 2B. Also, I would want you to remember that for any point on the ellipse, as how an ellipse is defined, the sum of its distances from the foci is 2A. So let us try to draw now the ellipse that we have derived in our session 9, in the 9th session of this series of video lessons, where the ellipse was a horizontal ellipse. The major axis was horizontal, and the center of the ellipse was at 0, 0. This is the center of our ellipse. Okay, f sub 1 was somewhere here. It's aligned with the center, but it's horizontal. F sub 2 was here. We have v sub 1 at this point and v sub 2 here. Then we have w sub 1 here and w sub 2. When we graph this ellipse, we connect the points with a smooth curve. Alright, let's have it here. Okay, let that be our ellipse. And so this ellipse, as what we have discussed and as what we have derived in our 9th session, has the equation in standard form: x squared over a squared plus y squared over b squared equal to 1. Here, A is greater than B. Actually, in all of the four cases, A is greater than B. And the center, let's try to write it here. The center of our ellipse is at 0, 0. Now, let me show you the graph of an ellipse where the foci aligns with the center vertically. It's not anymore looking like this. Let this be our x and our y. Okay, and so this second graph, I'm going to show you how an ellipse would look like if the center is still at the origin, but the foci are already aligned vertically. Okay, so if that is the case, then this would be our f sub 1, and this is our f sub 2. And since the vertices will be aligned, the vertices are collinear with the foci, then this would be our vertices v sub 1 and v sub 2, and this would be our co-vertices w sub 1 and w sub 2, and we connect the points with a smooth curve. Look how it looks like now. Okay, so that's how the ellipse would look like. And the equation here By the way, the equation of this type of ellipse in standard form would be x squared over b squared plus y squared over a squared equal to 1. Notice the difference between the equation of a horizontal ellipse and the vertical ellipse. In this case again, a is greater than b. So as you can see, since a is the distance from the center to any of our vertices, okay, so a is this point up to here, this is a, and this is also a. So the a, if you are going to look at that, the a is below the y. In this second graph, the equation here is that the a is already below the y. But on the first one, the a was below x, okay? And the graph is horizontal. Look at that, it's horizontal. While on the second one, the graph is vertical. The vertices and the foci and the center are aligned vertically. Whereas on the first graph, the vertices, the foci, and the center are aligned horizontally. Now let's proceed to the graph where the center is not anymore at the origin, but rather the center is somewhere else in the Cartesian coordinate system. Okay? Try to check this out. Okay, so here the center would be at HK, somewhere else, not at the origin. So if we will have a horizontal ellipse, then let this be our center. Okay, so f sub 1 could be here, f sub 1, and this could be f sub 2. Let me balance that out. This could be, let this be v sub 1, and this one v sub 2. And so this one, let this be one of our co-vertices, w sub 1, and this one is w sub 2. And then this is our center at HK. Here, the point here is HK. Let's connect out the points with a smooth curve. Alright, so this is how the graph of our ellipse would look like. Okay, so as you can see, this is now our major axis. This one is our minor axis. Oh, by the way, this is our x line and our y line. So what's the equation? What's the form of the equation in standard form of this type of ellipse where the center is already at HK and the orientation is horizontal, the major axis is horizontal? The equation of this type of ellipse would be x minus h over a squared plus y minus k squared over b squared equal to 1. Okay, and for this second one, let me draw an ellipse wherein the foci and the vertices and the center are aligned vertically. So let this be our center at HK, and so let these points be our f sub 1, and this is our f sub 2. Let this be v sub 2, and v sub 1 is here. And let this be w sub 1, and this one w sub 2. And then we connect the points with a smooth curve. Alright, so that's how our ellipse would look like. Okay, so as you can see, this is already our major axis, and this one is our minor axis. Alright, so how will the equation of this type of ellipse would look like? It would be like this: x minus h quantity squared over b squared plus y minus k quantity squared over a squared equal to 1. Notice the difference between the two. As what we can see here, the major axis is already vertical, and it's the a here, the a is below the y, just like what we had with the center at 0, 0. While in the first graph here, the equation, the a squared is below x, okay, and the major axis is horizontal. So always remember that when we write the equation of an ellipse, we know that the form would look like this if the center is at HK and the major axis is horizontal. The longer side, the longer segment that will divide the graph into two equal parts, the 2A, okay, this one is 2A, V sub 1 to V sub 2. It's horizontal and A is below X. But when it's vertical, the A is below Y. So that is your hint to know whether the ellipse is vertical or horizontal. In this case here, the major axis here is horizontal and the minor axis is vertical. And the second one, the major axis is vertical and the minor axis is horizontal. This is also the same with the graphs where our center was at the origin, 0, 0. Alright, so that's how we are going to, that's how the graphs of an ellipse looks like and the different variations of the equation depending on the location of the center of our ellipse, whether it's at the origin or it's somewhere at HK, somewhere in the Cartesian coordinate system, not at the origin anymore. And just remember that the A would always be below X if the graph is horizontal, and the A would be below Y if the graph is vertical. And in these four cases, this third case here, again, A is greater than B, and in the fourth case, it's the same thing, A is greater than B. And that C, the distance from the foci, from one of the foci, from the focus to the center, C would always be equal to, let me write it here, C is equal to the square root of A squared minus B squared. That's it, math learners. I hope you have learned something today as we explored more on the graphs of ellipses and the equation of ellipses in standard form. Stay safe always. Bye!